Question 8b is asking us to find the length of segment AD. So that's this segment right here. So in the last problem, we saw that the side length here is 5. So I'm going to redraw these two triangles, but I'm going to have them oriented the same direction. So I'm going to put this one here, and then I've got my hypotenuse. So this will be BDC. So we've got B, D, and C. And then I also have this triangle over here that I'm going to recreate. And I'm going to orient it the same way so that the right angle is at the bottom left. And this right here. Okay, so now this is triangle ADB. So we've got right angles here and here. I know that BD is 5. I know that DC is 12. And I know that BC is 13. In this triangle, I'm looking for AD, and I know that BD is 5 because this segment here is the same as this segment right here. So I have two similar triangles. If you remember this triangle from before, these two angles here are the same as these two angles here. So I have two angles in this triangle congruent to two angles in this triangle, which means these two are similar triangles. So when I find missing lengths of similar triangles, I can set up a proportion. So when I set up my proportion, I always want to start with the variable that I'm looking for first. And then I want to, underneath that, I want to put what it's corresponding to. So x over 5 is equal to, now I have to come back to this original triangle because that's what's in the top over here. So that's what has to be in the top over here. So these two have to correspond and these two have to correspond. So 5 is going to go in the top here. And then in the denominator over here, I have to go with whatever corresponds with 5. So this would be 12. So we get x times 12, because 12 times x is equal to 25. So to figure out what x is equal to, we're going to divide both sides by 12. So we're just going to leave this because it doesn't come out as a really nice decimal. So these two 12s simplify, and we're left with x is equal to 25 over 12.